RCHUB International Foundation for Research and Education, an ISO certified.
The statistics is what the statistics is all about, because many of them personally feel that the statistics is difficult since it deals with numbers, and we need to learn the formulas, we need to memorize the formulas, we need to rightly apply those formulas in order to know the result exactly. The thing is that the the things have changed to a great extent that you don't need to memorize any formula. And the perception of statistics dealing with numbers, yes, statistics deals with number, but indeed the foundation lies on only two important things: the type of data and the type of analysis what you're going to perform. Only these two things. So basically, statistics is simple. So when I say, when you are with me for next 1 hour, you will clearly understand that the statistics is simple. So only if you understand the foundation of statistics, we can get into SPSS, which is also a software application specifically designed to perform statistics on social science studies. Okay. So let me present, I hope my PPT is visible. So let me, is my PPT visible? Is my PPT visible? Okay, okay. So my
Yes. Yes, sir, it is visible.
okay, ma'am. So when I tell you, when it comes to statistics, we all know it involves data collections. It needs to be organized. It needs to be scrutinized. Only then the scrutinized data set could be analyzed and made interpretation. Then it need to be presented in the form of chapter or a PPT in order to get a clear discussion to get into a discussion. But the foundation of statistics lies, if you look at the statistics, it could be classified into only two categories. Statistics is not like, you don't need to think about the ANOVA, you don't need to think about independent paired sample t-test or one sample t-test or some other correlation, regression. Forget about it. When you think about statistics, the statistics could be broadly categorized only into two types. That is descriptive statistics, and second is an inferential statistics. So what is this descriptive statistics and what is this inferential statistics? So as a name suggests, a descriptive statistics is nothing but it describes a data set. It describes a data set. So for example, you are doing a data analysis on stock market. You are doing data analysis on a stock market and you are watching over a particular stock. Say for example, Tata, okay? Tata Motors. So Tata Motors, you are seeing for past 1 year, that is 365, no, the something like 260 working days. So when you look at it, you found that the Tata Motors share price on an average, it was 264. So what is this on an average? The mean value. It is nothing but the mean value. And it is from 264, it's either deviating 32 rupees plus or 32 minus less, which is called as a deviation. So you may clearly describe that, yes, the Tata price or the Tata Motor share price is approximately on an average, it has been traded at 264 for this past 1 year, and it's hardly deviating 32 rupees plus or minus. So you describe a data set, right? So this is what is called as descriptive statistics. So this is what is called as a descriptive statistics. Whereas inferential statistics is something you perform to identify only four important things. So statistics on the whole, you will be doing only these five things together. Whether the two variables, inferential statistics is done to find whether the two variables what you have considered is having association with one another. Whether the two variables what you are considering has the relationship with one another. Whether the two or more variables what is you are considering for the study is influencing the one another, or is there any significant difference in the variables. So it is for these five reasons you are performing statistics. Let me repeat. You are performing the entire statistics only for these 5 reasons. First, to describe the data set. Second, to find whether there is significant association between the variables you have considered for the study. Or is there any significant relationship between the two or more variables what you have considered for this study? Or is there any significant influence of one variable on the other variables considered for your study? Or is there any significant difference in the variables for the study? It may sound almost same, but let me make it clear. The thing is that there is a slight difference between each and everything. So you may think, what is this difference between significant association and significant relationship? Both means the same. No, they are completely different. From what perspective? The data type what you're using is really going to determine whether it's going to be significant association or relationship. So on the whole, you are performing this entire statistics only for these 5 reasons. It's very simple. Statistics, as I stated before, is very simple. You are doing the entire statistics only for this 5 reasons: to describe a data set, or to find the significant association, or to find the significant relationship, or to find the significant influence, or the significant difference. It is for these 5 reasons you are performing this entire the statistics. I'm not talking about mathematics, I'm talking about statistics. So when I say about statistics, when it comes to research methodology, you might have heard about there are different types of data, like ratio data, scale data, the ordinal data, nominal data. But I tell you what, forget about it. When it comes to statistics, there are only 2 types of data. When it comes to statistics, there are only 2 types of data, and it is based on this you are going to find what kind of analysis I need to perform for my questionnaire, what I have framed for my study. So fundamentally, the data types only decides what kind of analysis has to be performed. So when it comes to statistics, there are only 2 types of data. One is metric and another is categorical. So when it comes to SPSS, you have 3 types, that is scale, ordinal, nominal. But still, here also, what kind of analysis you need to perform, you will be following only the statistic foundation principle, that is the metric and categorical data. So you may have a question, what is this metric data and what is this categorical data? The categorical data is any data that groups the sample. So for example, male, female, these are a group like, and a smoker and a non-smoker. So this is once again a group. A person who prefers tea, who prefers coffee, it's a group. Then so this is what is a categorical data. And comes the metric data. Any data that deals with numbers, Say, for example, you ask, what is your weight dash in kg? Say, for example, one person will be telling 82, one person will be telling 92, one person will be telling 86, 76, 74. It could be of any number. It could be of any numbers. So any data that deals with numbers, say, for example, you are asked, what is your current income level dash? It could be of any numbers. And you are asking, what is your height in centimeter dash? So this could be of any numbers. So these kind of data is called as a metric data. But the most important thing is that most of the time, the social science researchers convert this metric data into categorical data. How? The first thing is that they will group it like this: less than 25,000 as an income, 25,000 to 50,000 as an income, 50 to 75,000 as an income, 75 to 1 lakh as an income, more than 1 lakh mentioned. So now what you have done is that you are not asking a specific number, you are grouping them. So which means this is a categorical data, this is not a metric data. And similarly, even age groups, you will make it as a group, say less than 25 years, 25 to 35 years, 35 to 45 years. Now it becomes a group. If you ask what is their age dash in years, then it is metric data. But if you segregate it into categories, groups, then it is called as categorical data. This is what you have to understand clearly. And then comes Likert scale based question. Say for example, most of the social science studies uses Likert scale based questions. So what is Likert scale based question? It could be a 5-point Likert scale or 7-point Likert scale. Say for example, how far you agree this statement? Strongly disagree or disagree, neither agree nor agree, disagree or strongly agree. So it's a 5-point Likert scale. So any Likert scale based question having the sample size more than 60 should also be considered as a metric data. So any Likert scale question with a significant sample size and any data that deals with numbers is a metric data. So these all are the two fundamental types of data with respect to statistics. So I hope now you have understood the two important things. So statistics is not difficult. And the first important thing when it comes to statistics, we are doing statistics only for 5 important reasons. To describe the data set, that is descriptive statistics, or to find the significant association between the variables, or to find the significant relationship between the variables, or the significant influence of one variable on the other variables, or significant difference between the variables. It is for these 5 reasons we perform the entire statistics. So in order to perform the statistics, you have to understand what is categorical data and what is metric data. This is the second thing what you have to understand. So what is a categorical data? Anything that forms a group in a questionnaire. That is what is called as a categorical data. Metric data could be any data that deals specifically with the numbers or a Likert scale based options. So these with a significant sample size of 60 and above. So these is called as a metric data. So now we understood the two concepts. So now let's move on to the third important concept. So I told you there are only two types of data. With these two types of data only, you are going to decide what kind of test you need to perform for your study. Say, for example, for both the data are categorical in nature, at that point of time, you need to perform significant association test. So note it down. So because these kind of open statement you won't be getting from any statistician. So try to note it down, take it to heart. Okay. So if both the data are categorical in nature, you need to perform significant association test. If one data is categorical and another data is metric, at that point of time, you have to perform significant difference test. If both the data are metric, then at that point of time, you have to perform significant relationship test or significant impact test. So when it comes to statistics, these are the 4 important reasons, right? Describing the data set anyone could do. So apart from that, if one variable is categorical and another variable is metric, at that point of time, significant difference. If both the data are metric, then you need to perform significant relationship test. If there is significant relationship, you need to go for significant impact test. If both the data are categorical in nature, you need to perform significant association test. So this is what is statistics. This is what is statistics. Say for example, now you may have a question. Sir, you told me if both the data are categorical in nature, we need to perform significant association test. What test do I need to perform? So, if both the data are categorical in nature and you need to perform significant association test, there are only 2 statistical tests to test the association between the variables. One is the chi-square test and another is the correspondence analysis. So there are only 2 tests. Okay, so as simple as this. Now you may have a question. If 2 data are categorical in nature, we need to perform significant association test. Is it logically right? Yes. Say for example, you are going to a cancer institute. You are going to a cancer institute, and you are asking the respondents. You are asking the respondents. Are you a smoker or a non-smoker? Are you a smoker or a non-smoker? So this is a categorical question, right? Smoker, non-smoker. Are you a cancer patient or a non-cancer patient? So this is also a categorical data, right? And you found that most of the smokers are cancer patients. So now you can say that there is significant association between the smoking and the smoking and cancer. You can say, right? So you have asked two categorical question: are you a smoker or a non-smoker? And another categorical question is that question with categorical option is that are you a cancer patient or a non-cancer patient? And you found that most of the smokers or cancer patient, which means we can say that there is significant association between smoking and cancer. So it is for this we use the chi-square test or the correspondence analysis. So now you may have a question. So now you may have a question. Why can't we say significant relationship between smoking and cancer? No, we cannot say. A relationship could be both positive and negative. So in order to do a relationship test, both the data has to be metric. Both the data has to be metric. I say why. So for example, for relationship test, there is only one test, that is correlation analysis. You have no other test. So for the association test, there are only two tests, the chi-square test and correspondence analysis. And there is a separate criteria, a set of criteria when to use the correspondence analysis. And similarly, when it comes to relationship test, both the data has to be metric. And if both the data are metric, at that point of time, you need to use correlation analysis. So when it comes to correlation analysis, so both the data has to be metric. I told you, right? So for example, we know India population is studied in terms of number. India population is always in terms of number, and India's GDP is also in number. So whenever India's population increases, India's GDP decreases. Have you understood? It is obvious, right? When the population increases, the GDP decreases. So there is a negative relationship. Both are numbers only. Both are number. Population is also a number. GDP is also a number. But when the population increases, GDP decreases. This is what is called as negative relationship. And similarly, whenever the industry index, that is the number of cluster of industry increases, the GDP increases. The industry index is also measured in terms of number. GDP is also measured in terms of number. So whenever the number of industry increases, the production increases, the products that is produced also increases, which increases the GDP, the gross domestic product. So there could be a positive relationship and negative relationship. Let me keep it like this. Say for example, let me consider someone as an example. Yeah, say for example, Anita or Biswajit. Say for example, Biswajit and myself are running. And you all know that while we are running, the speed is measured, the speed kilometer per hour. Okay. The speed is measured in terms of kilometer per hour, which is number. So myself and Biswajit are running in one direction, the same direction. So what is happening here is that I'm a little bit slow. I'm running at only 8 kilometer per hour, whereas the Biswajit is running at 10 kilometer per hour in a marathon. So what is happening here is that we have 80% relationship. We could say, right? There is 80% relationship. For example, when Biswajit covers 100 meter, I will be covering only 80 meter. When Biswajit covers 200 meter, I will be covering only 160 meter. So what is happening here is that we have relationship, we have positive relationship. But in case, if I'm running in a backward direction and Biswajit is running in a forward direction, do we have relationship? The answer is yes, we do have relationship because we are doing the same activity, we are running. But the difference is that when Biswajit moves forward by 100 meter, I will be moving backward by 80 meter. We have negative relationship. So when he covers 100 meter forward, I will be covering 80 meter backward. So we have negative relationship, 0.80% negative relationship. So this is what is it. So in order to find the relationship between the data, both the data has to be metric. Whereas you can here, when it comes to significant association, you cannot say there is positive or negative association. You can say there is only association. The smoking and cancer has some association. You cannot say there is positive association, there is negative association, because these are categorical data. Logically, these are categorical data. So we cannot say positive or negative. So when it comes to relationship test, we can say there is positive relationship or negative relationship because these are in numbers. We can say whether the numbers moving along or moving against one another. So that's a beauty. Now, I hope you have understood the difference between the significant association and significant relationship test. So the name, the sound may be similar, but the thing is that statistically these are completely different. Many, because when I look at the thesis while I am reviewing, I see that many of the scholars unanimously make mistakes in the chi-square test. They will be telling there is significant relationship between the variable. That is not statistically right. The chi-square test is specifically done to find the association, not the relationship. So there is difference. That's what you have to understand. The relationship test is different from the association test. Okay. So now let's move on to this significant influence test. Now we have found that the two metric data has the relationships. For example, the population and GDP has a negative relationship. So you wanted to know how far the population is influencing the GDP, how far this GDP is being influenced by the population. At that point of time, you will be doing regression analysis, which is a third important thing with respect to the statistics. So you are, the fourth important thing with respect to the statistics. So if both the data are metric, try to find whether both the data have significant relationship with one another. If there is significant relationship, try to do the regression analysis and try to identify whether one variable is influencing the other variable. If so, how much they are influencing. That I will be teaching you, ma. So this is what it is. And then comes finally the significant difference test. The significance difference test. So if one data is categorical in nature and another data is metric in nature, at that point of time, you will be doing significant difference test. All kinds of t-test falls under this category. Say for example, yeah, say for example, yeah, myself, I'm using Royal Enfield Meteor 350. And one of Biswajit is using classic 350 Royal from the Royal Enfield. And we wanted to know whether there is a difference in mileage or what. Here, what is the categorical data? The categorical data is Royal Enfield Meteor 350, Royal Enfield Classic 350. These are two different bikes, right? So this is the categorical data. What is metric data here? Mileage. For 1 liter of petrol, how much the Meteor 350 is giving the mileage and how much the Classic 350 is giving the mileage. So we have tested 1 liter with 10 times. So for pouring 1 liter, we checked the mileage at one point of time in highway. Pouring 1 liter, we have checked the mileage on the city. So like that, we have measured 10 times and it was found that the Meteor 350 is giving a mileage of 28 km per liter, whereas Classic 350 is giving 32 km per liter. So now what you will say, there is significant difference in mileage, right? You won't be saying significant association in mileage. You won't be telling significant relationship in mileage. You will be telling, yes, there is significant difference in mileage between the Royal Enfield Meteor 350 and Classic 350. That is what is logically right. Sounds right, isn't it? So that's what it is. So when one data is categorical in nature, another data is metric in nature, at that point of time, you will be doing significant difference tests. What are these significant difference tests? It could be one sample t-test, it could be independent sample t-test, it could be ANOVA, it could be paired sample t-test. All these tests comes under significant difference test. So these are the fundamental tests of statistics through which you may interpret almost because nearly 70% of the analysis what you do for the research is these things. Only remaining 30% may fall under some other categories like EFA or a CFA with SEM and the cluster analysis or the or the optimization analysis or analysis using the secondary data using e-views data set, only 30% of the analysis falls under these categories, whereas 70% of the analysis is what I have spoken right now. So there are significant difference tests you for non-parametric significant difference test, that is Man-Whitney test, Wilson sign rank test. These kind of tests are specifically done when your sample size is low. So these are the entire statistics. I hope the statistics I have made it very clear, and this is what this entire statistics is all about. So let me repeat once again, take everything to your heart, right? Because none of the statisticians will illustrate these kind of things because these are completely different for them. When it comes to statistics, we are doing statistics only for the 5 reasons: to describe the data set, or to find a significant association or a significant relationship between the variable, or significant influence of one variable on another variable, or a significant difference. And when it comes to statistics, there are only two types of data. Either it could be a categorical data or metric data. So what is categorical data? Any data that forms a group is categorical data. Any that deals with numbers or Likert scale option is called as a metric data. So when we make the combination of this, when both the data are categorical in nature, at that point of time, you'll be doing significant association test using the chi-square test or correspondence analysis. And if both the data are metric in nature, at that point of time, you'll be doing significant relationship test using correlation analysis. And if that relationship, then you will be doing regression analysis to identify whether one variable is influencing the other variable or impacting the another variable. And if one data is categorical and another data is metric in nature, at that point of time, we will be doing significant difference tests. All kind of tests, one sample t-test, independent sample t-test, ANOVA, paired sample t-test, all comes under the parametric test. There is also non-parametric test in case your sample size is low. Say, for example, for independent sample t-test, you have Man-Whitney test. For paired sample t-test, you have Wilson sign rank test. For ANOVA, you have Crystal-Wallis test. So this is the entire, almost 70% of the statistics. Is this thing clear, ma? So now can we move on to the SPSS? So let me close this PPT. Now let me open the SPSS software. Is my screen visible?
No.
No, right? Just for on. Okay. So, is it now visible?
Yeah, it's done.
Okay. So when you open the software, this sorry. I think only this thing is okay. So this is the screen that will be visible when you open the SPSS software. So when you wanted to create a new SPSS source file, what you have to do is that you need to click the new data set and click OK. So this is what is the SPSS window. So when it comes to SPSS window, the two important tabs what you have to understand is the variable view and next is the data view. Let me repeat. The two important tabs in the SPSS are nothing but the variable view and the data view. So what is this variable view? this variable view is a place where you type the questions and its corresponding options, and you will try to see that the right measures, that is the data type, is being selected. And in the data view, the corresponding options in terms of number is being pasted here. I tell you, this SPSS software does not understand any words. It understands only numbers. And based on these numbers only, it is going to perform the statistics. So this is the window, and it has two tabs, variable view and data view. Now, let me explain. So I hope this is visible. My questionnaire is visible. So is my questionnaire visible? Is my question?
Yes, it is
Yes, sir.
visible.
Okay. So this is the questionnaire mark. Say, for example, the first question is, I serial number that you leave it. The second question is gender. For gender, it has two options, male or female. And now tell me whether it's a categorical data or a metric data. Because you have to understand what analysis you need to perform for your own questionnaire. So now you see this is, yeah, correct. This is a categorical data. So gender, it has two options, male and female. Whereas age, is it metric, is it categorical or metric data? It's a metric data because I have not grouped into options less than 25 years or 25 to 35 years or 35 to 45 years. I not grouped. I simply asked age dash. So similarly, what is your highest level of education? School or diploma or graduate or postgraduate or other professional degrees. Similarly, what is your current occupations? So these are the questions. And what is your area of residence? And what is your monthly income? I am not segregated into categories. I simply ask what is your monthly income dash. How often you purchase beverage? It is related to a particular beverage brand in Tamil Nadu. It is for this entire questionnaire has been framed. So on daily basis or weekly basis or once in 2 weeks, how much ml bottle you buy? So a reason for the purchase, it is because you are thirsty or friends party or family functions or other reasons. Where you exactly buy? For this, I have made multiple options. He could make tick mark in anything. So these are all the questions I have. Which company you think is a major competitor for this particular beverage brand? That is, it's in Tamil Nadu local brand. So Coca-Cola or Pepsi or Tropicana or other locally produced. How satisfied are you with this following aspect? Price, product quality, product price, and product availability. So these are the questions I have framed. So in order to feed these questions, into, yeah, in order to feed these questions, what you have to do is that you make it small. Yeah. Sorry. Yeah. I hope now both the windows are visible, my SPSS window as well as my PPT. So now you have to look me keenly. So how I'm feeding the questionnaire into the SPSS. So what is my first question? Gender. So here in the label column, you're going to type the question. So I'm going to type gender. Okay. So in the value column, I'm going to type male and female. You see, there are two options, male and female. And I told you, right, when it comes to SPSS does not understand words. It understands only numbers. So I'm telling that if I type 1 in the data set, you have to assume it's male. If I type 2 in the data set column, then you have to assume it's female. So I'm instructing the SPSS software that if I put 1 in the data view, it is assumed that it is male. If I put 2, should be female. So Now our first question is typed. So let me put it as D1. I don't want as VAR0001. I want it as D1, demographic question 1. I tell you why this VAR001, it will become little bit clumsy and confusing when you are dealing with so many questions. Under a particular factor, if there are only 10 questions, if you put a particular name for that and you put 1, 2, 3 serially, it will be easy for you to identify in the data view. Here you see it is visible as D1. Similarly, if you have for a particular factor, you have 4 questions. 4 questions. Say, yeah, we have here we have 3 questions, right? Yeah. Oh, what do you think about the product quality, product price, and product the thing? So you can type it as P01, P02, P03. So it will be easily understandable. So okay, let me move on to the second question. So what is the second question? Age. So I'm going to put it as age. But here, if you see, there is no option. So what I'm going to do is that I'm going to simply leave it as blank. So I'm going to put this as D2, the demographic question 2. And most important thing is that I'm going to select the data type. Now, if you take a closed loop, gender is a categorical data. The categorical data is nothing but the nominal data. Why nominal data? If you take a closed loop, you have 3 circles. And if you zoom it, you will see that all these 3 circles does not touch one another, which means these are completely different groups. So that's what I'm telling. So this is nominal data. When it comes to statistics, there are only two data types, categorical and metric. But here SPSS, there are 3 data types. That is nominal, ordinal, and metric, a scale. So here, if you take age, it is scale, it is of number. So I'm going to select it as scale. Similarly, I'm going to type the next question. What is our next question? The next question is the highest level of education. I'm going to write it as highest level of education in the label column. Similarly, in the options, we have so many options. The first option, if I put 1 in the data view, it means he have did only school level. He has only school level education. If I put 2, it means he have completed diploma. Similarly, 3, he is a graduate. 4, he is a postgraduate. And 5, he has other professional degrees. Okay. This is the demographic question, third question. And similarly, what is your current occupation? Occupation. So let me copy paste this. Okay. You can also copy paste. You no need to type each and everything. Any version of the SPSS greater than 20 will accept copy paste option. Okay. So try to use the SPSS latest version. If not, at least greater than 20. So I have copy pasted. Housewife as a first option. The second option is student. The third option is the self-employed. The fourth option is government employee. Private sector employee. And the sixth option is unemployed. So now you have understood how to type the questions into the SPSS. But in case, as I stated here, the 11th question, where you generally buy the beverage. So it could be of any of these. He could have tick marked in fresh fruits and vegetable shop, bakery shop, grocery, dairy, or he could have checkbox 3 options. So if there is a checkbox based question, what you have to do is that you have to put yes or no options here. You see, you have to put yes or no options here. So I have this. This is buying place. So let me put it as BP1. So BP1. This is buying place 2, buying place 3, so that it will be easily identifiable by me while in the data view. So BP6. The option is yes or no. First is yes. If he have made tick mark in the particular option, it means yes. If he have not made any tick mark, it is no. So you can also copy paste this thing. Copy paste. That's it. Similarly, ranking questions. If there is a ranking question, what you have to do, you have to simply put the value. For example, if there is 1, 2, 3, 4, then you have 4 ranks, right? So you have to say, for example, let me do it. If there is a ranking questions, okay, if there is a ranking questions like this, what is this? Coca-Cola, Pepsi, Tropicana, and other local beverage. Okay, at that point of time, what you have to do is that you have to, there are 4 ranks. It could be of any of the 4 rank, right? So 1 means 1, 2 means 2, 3 means 3, 4th rank means the 4th rank. So it could be of any rank. So 1 to 4. That you have to put it like this. So if there is any ranking based question, you have to put it like this. So this is ranking based question, R1, R2, R3, and R4. Similarly, this question is as we have discussed before. You have to the product quality. You have to type the questions, that is product quality. For this particular factor, that is how satisfaction level of the customer as a factor, there are 3 important variables. That is 3 important questions. That is product quality, product price, and the product availability. Okay. So for this, the options are strongly disagree. Let me put it in short. Strongly disagree, SD. 2 is disagree. 3 is neither agree nor disagree. And 4th is agree. And 5th is strongly agree. So let me copy paste the same to other options also. So this is how you have to feed the questions into the data set. Later, you have to decide, you have to select the whether it's nominal data or the categorical data or a scale data. Copy, let me copy. Yes, these are yes or no questions. Everything comes under this one. And if you look at this one, this is scale once again because it's rank. But if you take a close look at this, it's step by step, right? Strongly disagree, neither agree nor disagree, agree and strongly agree, which is step by step. It has equal thing. That is what is called as ordinal data. So this is how we have to feed the questionnaire into the SPSS source file. So in order to feed a questionnaire into the SPSS source file, open the SPSS sheet, and then in the variable view, what you have to click on the variable view, type the questions in the label column, type the options in the value column, and select the measures in the measure, select the data type in the measure column. These are the three important tasks you have to do with respect to SPSS while feeding the questionnaire. Other thing by default are right, so no need to think about it. So coming to the data view. So data view, what you have to do is that you have to look at the response. You have to look at the response and then you have to feed the data. Say for example, this is the questionnaire. Let me click close. So this is the response sheet, ma. I hope it is visible. It's visible to everyone. So he have the first respondent is a male. So the first, yeah, the first respondent is male. So what I'm going to do is that I'm going to put 1 here. Why? Here in the demographic I state, if I'm going to put 1, it is male. You have to assume it's male. The second is that in the second question, the D2, the age, I'm going to put it as 28. You see, the respondents have stated his age is 28 years. I'm going to put 28 years. And he has the highest level of education he have is postgraduate. That is 1, 2, 3, 4, the fourth option. Let me cross verify here also. Highest level, fourth option. So I'm going to put 4 here. Similarly, I am going to look at the current or current current occupation. So which I named as BP1. Okay, current occupation. The current occupation is that he is a private employee, which is the sixth options. I hope it says sorry, private sector. It's a fifth option. And similarly, if I go to this questions, this particular, where, if you take, he buys the beverage from bakery or grocery or the general merchandise. So, let me rename this. This is also demographic 4 question. Sorry. This is beverage 1, 2, 3, 4, and 5. Okay. So the fresh and fruits, he have not made any tick mark. So I'm going to put 2 here. Why? You see, if there is no tick, it's no. So I'm going to put 2 here. Whereas for bakery, I'm going to put 1 here because he have made tick mark. Yes, he used to buy the product from the bakery, beverage from the bakery. Similarly, for grocery also 1. Whereas from dairy products, 2. No, he does not buy. And for general merchandise, once again 1. So that's it. Similarly, when it comes to ranking, you see he have made 1, 2, 3, 4. 1, 2, 4, 3. For Coca-Cola, he thinks that is a first competitor. And then Pepsi as a second competitor. Tropicana as the fourth competitor. Local beverage as a third competitor. So now I have made the rank. Similarly, the next question. He have made 4, 4, and 5. So that is 4, 4, and 5. So you see, I am feeding all the data in terms of numbers only. As I stated before, this SPSS does not understand any words you are going to give. So you have to feed the questionnaire in the variable view and you have to feed the data set, the collected response in the data view in terms of numbers. So this is what is SPSS feeding the data. So now if you take a close look, we have a data set. I have actually they fed the entire data set. This is the original data set collected for this particular project. So if you take a close look, we have framed all the questions, that is serial number, gender, age, highest level, everything in all the data has been stored here. All the data is been stored here. So in the next class, I will be illustrating how to perform a descriptive statistics and inferential statistics. Till now, do you have any doubts in today's session, Ma? Is everything clear? Do anyone, yeah, is this software? No, ma, this software is not free, but there is a software very similar to this one, which is completely an open source software. We call it as PSPP. This software is a completely open source Linux based software, which you can install it. And the most fascinating part is that the dashboard, the output, the result, everything is very, very intact with the SPSS. If you look at the PSPP dashboard, let me click it. You see the same, it is same, the name, it has variable view, it has data view. The variable view, it has the same column, name, the label column, the variable valuable options, the measure, all things are same. Even the output, if you take a close look, it remains the same. So that's the beauty of it. So when it comes to SPSS, no, it is not a free software. You need to buy it. But when it comes to a software that is very similar to SPSS, yes, there is a software called as PSPP, which is open source. Anyone could download and anyone could use it just like an SPSS. There will be not a single difference in the result or even in the way the result is projected. If you copy paste the output file from the PSPP, it will be way or equivalent to the SPSS. Even the alignment, even the table values, everything will be similar and same. So you can use that software in case if you cannot afford SPSS software. So if possible, in the next thing, if time permits, I will be teaching you all also the PSPP, which is the open source software. Okay. So apart from that, any other questions, ma? Anyone, any other questions? You
Sir,
can.
actually, we have stopped at this stage now. Tomorrow, I mean, in the next class, we'll be continuing from here. And what would be our objective from here?
Okay. So in the
So,
next
what is that
class,
I should? What is that I should be getting prepared for next class? We should be. We should be.
Okay, no issues, ma. The thing is that I will be explaining you about the univariate test. That is nothing but the descriptive statistics. And we also will be looking at the chi-square test, how to perform the chi-square test. So,
Okay.
then if
Okay.
possible, a significant difference test also. So I will be teaching 3 important tests to be performed, and I will be also explaining you how and what kind of data types you need to consider for making the analysis. What I really want you to do is that you might be having your own set of data. That is your own, you might have collected data from questionnaire through, you might have a data set. I want you to practice that because this, even if I give you the data set for practicing, the problem here lies is that you will try to forget because it does not have any application or with you. What you have to do is that you will be having the data set. Try to perform the analysis. Try to perform the analysis. Try to practice it. And if at all, if you have any doubts where when you have performed in this 3-day workshop, try to practice it. And on the analysis, what I have illustrated you, you can ask me during the next live session. The next live session which is going to come. So I will be trying to rectify the same. So tomorrow I'll be mostly covering the most important analysis that like significant association test, the significant relationship test, and if possible, if time permits, some of the descriptive statistics also. So try to practice it with your data set, and if there is any questions, you please feel free to ask me during the day after tomorrow, the live session. I will be trying to rectify the same. Okay. Do you get me, ma?
Yes, sir. Good. Thank you, sir. Thank you, sir.
So anyone, any other questions? Is today's session is everything, because this is fundamental. Most of the statistician will not teach you these things. So is this clear? Because if you understand these fundamental things, what for we are doing the statistics? We are doing statistics only for 5 reasons. What are the important data types in statistics? There are only 2 types of data types. And based on these 2 types of data, what kind of analysis I need to perform? That if you understand, and this SPSS becomes really a piece of cake. So, and the most important thing is that the SPSS, how to feed the questionnaire and how to cleanse your data set. That's very important. Apart from that, making the analysis is really, really easy. So that's what I'm going to teach you in the next 2 classes, because actually I spent so much time in this, because this is the foundation. If you understand this for your lifetime, obviously the entire statistics becomes very, very simple for you. So anyone, any other doubts, ma? Is everything clear?
Sir, a small doubt might be it is for
Yeah.
SPSS software for an individual. How much it would be costing, sir? Like I want to buy on my own, not as by through the organization where I am working for.
Okay.
How much it
Actually,
would-
it also varies, ma. The thing is that whether you are buying both are from it's from IBM.
IBM.
If you're going to buy only SPSS, the rate might be from 12 to 16 or sometime 20. If you're buying with AMOS, that is IBM SPSS and AMOS, the rate once again varies. And there is another inbuilt plugins that is also available for AMOS and SPSS. If you're going to buy all together, the rate varies. I don't know exactly the amount one, because I'm using SPSS 23, and as of now, whereas in the institution I am using SPSS 29 or 27, I think so. I don't know, the rate is drastically, the output is same, but the rate is different. I don't know exactly, but it ranges from 12 to almost 24 or 26 if you're going to buy as an individual.
Okay, sir. Thank you, sir.
Okay, ma. So thank you, Devaraju. So I hope everything is clear. So today, let's wind up. Tomorrow, everyone be on time, because we don't have time to waste. I need to cover lots and lots of topic, and at that same time, uh, we we are running out of time. So please be on time, and I will start everything on time. Okay. So thank you all. Thank you, God. We see. Take care. Bye.
Contact RCHUB International Foundation for Research and Education. WhatsApp 9888 231 231.